Good evening, millennials. Welcome to another LeetCode problems often tested in FAANG interviews such as Amazon, Google, Meta, etc. So let's look at the question. The question is the 103rd problem in the LeetCode website. You can visit the problem by hitting this address, or you can search for the 103rd problem in the Problems tab. So let's read the question. Binary tree zigzag level order traversal. So given the root of a binary tree, return the zigzag level order traversal of its nodes values, that is from left to right, then right to left for the next level, and alternate between. So let's look at more closely on what does this mean by looking at the example. So the given example is 3, 9, 20, 15 and 7. So we are given the root, which is this binary tree, and the output is an array of arrays with the first value as 3 and the second value as 20 and 9 from right to left, and the third value as 15 and 7 from left to right. So the first level it goes from left to right, and the second level it goes from right to left, and the third level it again goes from left to right. Okay, let's look at another example. When there's only one node, you have to only print it in the left to right order of the first level and 1. When the root is empty, you return an empty array. So let's look at the constraints. The number of nodes in the tree is in the range 0 to 2000. So this is an important information to test our validity of our solution. So since the nodes are between 0 to 2000, we can very well use an order of n or an order of n log n solution. And the value of the nodes are between -100 and 100. Okay. So since we need a level order traversal of the tree, we need to use a breadth first search algorithm. If you do not know what a breadth first search algorithm is, do feel free to look at our other video where I explain breadth first search algorithm in detail. So basically, to perform breadth first search algorithm, we need a queue, and we need to insert numbers of the tree into the queue in the corresponding order, so that when we pop them out in the corresponding order, we get a level order traversal. Once we do a level order traversal, however, on this tree, we would get an answer as 3, 9 and 20, 15 and 7 and so on. But we need to alternate the in-between layers. So what we need to do is, once after we perform a level order traversal, we just need to alternatively reverse the odd position indexes in the final array. So once we have a queue, we need to insert we need to perform a breadth first search level order traversal on the tree, and then reverse it. So that algorithm should work, and it's pretty straightforward. Okay, let's code on the fly and see how we can attend an interview. So we would traverse through all the nodes. That would be an time complexity of order n, and to sort it or to reverse it, it would again be an order of n. So we could do it in an order of n algorithm, and the space complexity would again be an order of n, as we must use a queue to perform a breadth first search. Okay, so let's declare our variables. So we need to return a vector of vector as it's asked in the question, as the output is a vector of vectors. So let me declare the vector of vector int answer, and we will be returning this finally. Okay, so let's take care of the base cases first. When the root is empty, you need to return an empty array. If not root, which means if the root is null, just return the answer. Okay, so now I try to create a queue and insert elements into it. So since it's a vector of vector int, we can't straight away know the number of levels in this queue at the beginning. We can either do a breadth first search twice to find the level of the queue, and then again do a breadth first search to put the elements, but that will be twice the work. So what I'll do is, I'll just increase the size of the queue on the go so that we can code more efficiently. So let me just create a queue with two things. So I need two things. One is the node and the current level. So to have two things. You can either use an array, or I'm using a pair since we only have two information that we need. So one is the tree node star and the other is a integer where we store the level and queue. And as we all know, for the breadth first search, we first push the first element into the queue, which is root, comma, and the level initially I'm going to have it as 0. So now I perform the breadth first search. So while the queue is not empty, what I do is I try to pop out each element and correspondingly push the left and right elements back into the queue. So the first element, so for the sake of readability during the interview, the first element of the queue would be of the pair tree node star int. So let me just declare another variable for it. So pair of tree node star comma int p equal to queue dot first. So this will be our current element of the queue. So once we it should be queue dot front. So it's the front of the queue. As we all know, queue works on the concept of first in and first out. So once we have taken out that element, we need to pop it out, as it's the case of breadth first search. Once you pop it out, let me rename two variables. Tree node star, just for the sake of simplicity I'm renaming this, but to make your code shorter you don't actually need to get these two variables separately. Tree node star current node equal to p dot first from this p above in line 20, and int level, which is the current level, equal to p dot second, which is what we are storing as I had already discussed. So now what we need to do is answer of level. In the current level we need to push underscore back of in this current level we need to push the value of the node. So it will be current node arrow value. But since we do not know the level of the tree, this might give an error during the breadth first search, as we haven't declared the size of the final array. So what do I do before this is, if answer the final array dot size is less than the current level, I just resize the answer to the is less than the next level, which is level plus 1. I just resize it to level plus 1 so that we don't cause memory errors. So answer of level dot push underscore back of current node arrow val. Now we need to push the left and right subtrees back into the queue. So all I need to do is queue dot push of current node arrow left comma level plus 1, as it will be in the next level of the BFS. And the second one, we need to push the right subtree, and it will be current node arrow right comma level plus 1. So this will create a level order traversal of the binary tree, which we have, and it won't have done the zigzag order yet. So after the level order traversal, we need to alternatively reverse the odd indices of the final array. So before this there's a catch. So this current node arrow left can be null. Also the current node arrow right can be null. In that case we shouldn't push the corresponding nodes. So let me just have a condition where if not of current node arrow left, if current node arrow left, which means it's not equal to null, we can push it. Similarly, if current node arrow right, which means the right one exists, we can push it. Okay, and I think this must be good. So right now we have a proper level order traversal of the tree, which will give us the output as 3, 9, 20 and then 15, 7. But we need to create a zigzag level order traversal. So what do I do is I just loop in through the final array for int I equal to 0. Don't create variables beforehand, just try to create it on the fly to save memory. I less than answer dot size and plus plus I. What do I do is, if I is odd, we don't need to change the order for the first level, which is the level 0, but we need to change this for the odd numbered layers. So I and 1 gives the odd number, checks whether I is odd or not. So what do I do is reverse of answer of I. So what I'm basically doing is I'm just reversing the answer of I, but this is the syntax in C++ language. So and at the end of this I need to return answer. So just let's look through the code and look whether we have any errors. So I declare the vector of vector int answer, and if not root, I just return the answer. Then I create a queue of pair tree node star and int of queue. Here I don't know the number of levels of the tree, so I am not aware of the size. So what do I need to do is, in each iteration of the BFS I need to resize the tree to the next level. So initially I push the root and the level, which is 0. So while not q not of empty, I create a pair of tree node comma int and I assign it to the front of the queue, and then I pop the front of the queue. Then I have two nodes, current node and level, which is p dot first and p dot second respectively. And then if answer size is less than level plus 1, I just resize answer to the number of levels it should contain. So for this current example, there are 3 levels, 0, 1 and 2. So the output will also have 3 arrays. So 1, 2 and 3. That's what I am basically doing here. So at the maximum, it will have the maximum number of levels. Else it would give you a memory overflow error when you try to access answer of level. So then in the current answer of level, I need to push back the value of node, arrow val. It's val, right? So here you can see the definition of the binary tree node, which is val. Okay. Then if current nodes left exist, I push the left and level plus 1 back into the queue. And if current nodes right exist, I push the right node and level plus 1 back into the queue. And once I have processed all this, I just reverse the odd numbered layers. So I think this code is good to go. Yeah, and it's accepted. Let me just submit it. Yeah, and it's faster than 100% of the C++ solutions, and it's also memory efficient of 99.12%. This is because we didn't calculate the level once and then again tried to do the BFS. We did only BFS once by using this innovative solution. Thank you. Please do subscribe to our channel.